is we're going to talk about what are called relative maximum and relative minimum. We're going to use the calculators to find these. When we graphed these before, we just kind of plotted our zeros, did our end dances to figure out which way the tails were going. But now we're just going to take it one little step further and utilize the calculator to find what are called relative maximums, relative minimums, and it really is just pressing buttons, and it's pretty simple. So a trace button does not work for this. You have to use the calculate button. Trace gives you an approximate, and the trace button will be wrong if you don't use the calculate button. So if I'm looking at this one here, what are your tails doing on this? You can probably tell right away.
Up.
They're up, right?
Oh, yeah.
It's up. This is the next square. Yes, ma'am?
I think my battery's dying. Oh, so is mine.
Mine.
There's this little...
Mine's dying.
Yeah, it's dying.
That's a problem.
Really bad.
Why you got your calculator taken away?
True.
Bad.
But I like this one better, so it's okay.
That's good.
Look at this.
Oh,
I lie good 100% of the time. 4 or 5 chances I was telling the truth.
it's mad. I'll tell you, I was upset. First.
No problem.
First day.
So we know that we would plot these things via the zeros.
I don't even like it anyway, so it's okay.
And we do the tails of doing something like this. We all agree on that?
Yeah.
What's going to happen though is we're going to take it a little bit further and we're going to set it up in terms of a larger polynomial. In this case here, it's going to, we have f of x is 1/4 times quantity x plus 2 times the quantity x minus 1 squared. This means that it's going to be a third degree polynomial with a leading term coefficient that's positive, and there's going to be 2 changes of direction. Remember how we did that where we did n minus 1 changes of direction off of your degrees? When we talked about that, I don't know, a couple weeks ago? We started our dances.
What do you think?
Thank you for maybe remembering. Anyway, thank you. What we're looking at here is we're going to be able to plot this with our tails via zeros. Okay? And then I'm going to show you guys how we're going to figure out these relative maximums and relative minimums on the calculator. So the first thing we do is our rough sketch. Where are your zeros? 1 and -2. So I know my zero is going to be at 1 and -2. What's special about the 0 at 1? Multiplicity. Very good. It has multiplicity at 1 because it's x minus 1, x minus 1. It's the quantity squared. Now, what way are the tails going for this? Which one is it? Down up. It's positive, so it's down up. So we know that's got to do this, change direction, touch here, and go back up. Now, what I want to do is show you guys in the calculator how we figure out what this value is. We call this value, do you think that's going to be a maximum value or a minimum value at that point? It's a maximum value because it's where it's changing direction. Since it's not the maximum or the minimum of the entire function itself, because the function is continuous going through there, this is what we're going to call a relative maximum. And then obviously this would be the relative minimum. That was very easy to find because we know where the relative minimum is because it happens to change direction on the axis. It's at 1, 0. The other one, we're going to use our calculator to find. So, go to your y equals.
Yeah.
You said that yesterday.
I did. Still.
Go to our y equals. It was what, 1/4?
Yeah.
A lot of times what you can do with your calculator is sometimes it's quicker to type the decimal in because the calculator doesn't matter. And then it was 1/4 quantity x minus 2.
X plus 2.
Thank you. And then x minus 1 quantity squared.
Yep.
And we'll go to our graph.
Ooh, look at that.
All right. Did everybody get something that looks like that?
Yeah.
Graph. Just put that function in. Y. Okay.
I got that.
So now what I want you guys to do is hit your second calculate button. And we're going to figure out the maximum. So you need to find that relative maximum within that where it changed direction there, which is option 4. Remember how it's going to ask you that left boundary and the right boundary?
Yeah.
What you want to do is make your cursor move to the left of where it looks like the maximum occurs. Oops, whoa, went a little too far.
Uh-oh.
The calculator on here is still very slow. Hit enter, then it's going to ask you to put the right boundary. You move over to the right of it. Hit enter, guess, it's raining. And then hit enter one more time. And it should give you some value of
I'm trying to find the right.
what would you call negative 0.9999999?
-1.
Negative 1. So you have what's called a relative maximum at the ordered pair of negative 1, 1. That's what we're looking at here, guys. You're going to plot your zeros just like you did before, and you're going to find that relative maximum and or the relative minimum using your calculator. That's it. Pretty simple, actually.
Right here is 1.
What's that?
What do you do with the 1?
Why are you complaining now? Sir,
Is it okay if we don't get exactly like the same thing as you?
you should be right in that range.
I have like negative 1.000. Right?
Yeah, and that's the reason why yours is probably at negative 1.00 because your range that you chose might have been a little bit narrower.
Okay.
It's going to be within that.
It's the same thing. Though.
Yeah, it's going to be in that same relative idea. Okay. All right, let's try another one. Let's do the same thing. Let's graph this via the zeros, and then we're going to find the relative maximums and minimums if they happen. So I have f of x is negative 2 times 20, x squared minus 9, then x plus 4. Which means, what's the degree of the polynomial?
3.
It's a third degree polynomial. Leading term coefficient is going to be positive or negative. So which way are we dancing? Up, down.
How do I move this?
Because it's negative, so it's going to go
Okay.
down, up. I'm sorry, up, down.
Up, down.
So now we have to get our zeros. Where are our zeros at? Negative 4.
And then it'd be square root of 3.
And then
3.
So I know it's got to do this. Something like that. And that's kind of the rough idea of what we did before.
something
But now, when we go into our calculator, we're going to be able to figure out how low this curve's going to go, how high up it's going to go, just by looking at that, what we're going to call a point of inflection. It's where it changes direction at the relative minimum and the relative maximum.
You can't see all of it.
You just mess around with your window. X plus 4.
Does it go like this? I have no clue. What are the arrows?
All right, so obviously we don't see where the maximum is occurring, correct?
Window.
Change your window. Well, actually, you know what? If you take your calculator and you tilt it and you look down there, you might see it.
Oh yeah, I see it.
Funny.
There it is.
I actually had a kid going on that one a couple years ago. Great. I was in tears trying so hard not to. See, you're laughing because you don't have your calculator, otherwise you would have done it.
This is my calculator.
That's a new.
What'd you set your window at for, you changed
100.
100 for the Y max?
Yep.
Why, Max?
Okay. That's the idea of being able to do that, is to adjust for your maximum for your windows and just playing around with it. You guys will get really accustomed to playing around with the window sets for a lot of style problems. It's going to help you figure these things out. Okay? So then it's just a matter of pressing buttons, and I think that's relatively simple. So we knew our zeros were at -4, -3, and +3. Where was my relative minimum? High. -3.5, -3.5?
Minimum.
Don't hit trace, it's gonna be off. Don't hit trace, hit second calculate for zero, for
Or
your,
wouldn't it be second trace, which can be calculated?
oh, I'm sorry, I thought you just hit trace. I'm sorry, I thought you were just hitting the trace button. Okay, yeah, second trace to go to that. And then our maximum, what's that?
Why do we need the minimum maximum?
Because that's what I'm asking you to find, the relative minimum, relative maximum. You're just using the calculator.
I'm just asking.
Mhm. That's those points.
Importance to this.
And what do we get? 0.85 and 80.3.
I didn't get it.
Well, you gotta get both.
That's 0.85?
0.85 and 80.29. I like you guys to keep going to two decimal places all the time, the hundredth, for these weird decimals. Okay?
Minimum.
Yes, ma'am. Yeah, the relative minimums, I think she said it was at -3.5 and then -3 1/4. I didn't do that one, so I'm trusting the crazy Ruski, so I don't know if that's the right thing to do.
It's correct.
It's correct.
Is it correct? Wow.
That's a
Sorry. All right, well, let's go into writing the cubic function then. This is the part of 6.9. We're actually going to go back to 6.8 and 6.9 later on in the semester when we circle back to do a bunch of this modeling stuff that we do. But I want to do a couple parts of it now because it fits really well into what we're working on. Sometimes you're going to be given just ordered pairs and or zeros, and you're going to have to write the cubic, or these are actually going to go with just straight cubics here. And the way that we were just writing them out a second ago looked like this. It was y equals some value a times all your zeros. Bless you. I'll call it L. H, A, and L are your zeros. I didn't want to use I. You can use J if you want. W, whatever. Z. I don't want to use X because it's okay. What's happening here is we're going to be able to write the function if I know the 3 zeros and I know one other ordered pair.
Okay.
All right.
What do we got?
So we have 3 zeros. We have zeros at -3. I have a 0 at 2 and a 0 at 5. So that means my 3 terms are going to be x plus 3, x minus 2, and x minus 5. We okay with that?
Yep.
What's the other ordered pair I'm given in this graph?
0, -15.
And I'm also given the 0 and -15. And that's a point on the graph. Well, using that 0 and -15, what could I solve for? A. Very good. I can solve for A. But if I'm looking at my graph right now, what should A be? Should it be positive or negative? Think about the tails.
Trick me.
Negative.
It should be negative because it's going down, or it's going up, down. Okay. So here's what we do. You're be given all that information. It's just a matter of substituting in and solving for A and then rewriting. So y equals -15 equals A times 0 plus 3, 0 minus 2, 0 minus 5. 3 times -2 times -5.
Because that's the point. That's the point.
What's A?
A.
Try again.
Wow, that's embarrassing.
It's very embarrassing. You know how many times you guys will do that?
He said it, so I just relayed it. So it wasn't
Excellent.
it wasn't my brain thinking.
It's -1/2. Remember, you gotta divide, guys. You know how many times you're gonna get that problem wrong all the time. Oh, it's 2.
Well, now I don't feel that bad about it.
almost right.
F is good.
Close enough.
Yes. So then you have your a value. Then it's just a matter of rewriting out the equation. So you get y would equal -1/2 x plus 3, x minus 2, and x minus 5. I haven't quite decided if I want to make you FOIL that out. I really don't think you need to, but there you go. Pretty simple, believe it or not. Straight up.
This is easier than the thing with those nice.
So I'm going to write the cubic function given those ordered pairs. I'm going to write the cubic function given the ordered pairs. So I'm going to make this look like this. Y equals a So which one of those are my zeros and which one of those is my ordered pair?
0.
Oh, zeros in the first year.
Ah, be careful. What is the value? Which one has to be the 0, the x or the y for the 0 of the function? Y has to be the 0. Very good.
1, 2.
So fill in the blanks right off the bat. We know that we're going to get y equals a, x plus 1, x plus 2. And if 0 is my 0, what's my term? X. Very good. And then I use my ordered pair of 1, -3. So you get -3 is a is 2 times 3, 1. 2 times 3 times 1 is? What's a? 1/2. It's not always -1/2 because that's the next question you're going to ask. Is it always -1/2? No. Yes, -3/6. Yeah, exactly. And then just go back and substitute.
What? Wait, what?
What do you want?
What?
Did you get what x equals? Like how x?
Actually, the 0 for that was 0, so it's x minus 0. Oh, how did I get what x was equal to? Sorry, it was given.
Oh, okay. So
You'll have to be given 4 ordered pairs. The other one it was on the graph, was that the y-intercept was 0 and -15.
Wait, so you have to have 4 pairs?
What's that? What's that? You could. I don't think so. Not so bad? Yes, sir.
you know which one is y? The one is y is the one that has 0. That's the like how do you know which one plugging for the y?
Oh, it's the one that has a y value. Because the other ones, if you look at it in terms of if you graph them, you'd be plotting zeros. The y value, if the y is 0, means it's on the x-intercept. This should be relatively straightforward, I'm hoping. Let me give you a couple of these. Consider real quick. A couple of these mixed up here to do.
Mr. Murphy.
You know I love that.
What's up?
Hey, Mr. Murphy.
Yeah.
Got a message for you. Aw, Grace. Oh, really? I saw you at Winter Break night. Winter Break night. I was actually going to do it with the me, but I forgot. What does he do? Wrestle. You wrestle? Are you on varsity? Oh, goodness. Graph via.
Yeah, I've always wondered what via means.
Wait, no, like that.
What's the definition of via?
Via graph by doing this.
Sounds like a car.
To go like,
Yeah.
Is that no? I don't understand this. I
Yeah.
can't. It was for language.
Basically, it's the same thing we just did. Graph via the zeros and end behavior, find those relative max and mins.
That's too much words. I was like, pulling everyone down today.
Prime Mind from Wizards of Oz. It's like something else.
What? There's more. Mr. Murphy.
The crime
Mr. Murphy,
line
can you
does
just
the
do, like, one of those,
cowardly
please?
lion.
Yeah, but he cries.
Wow.
I get. That's a pretty good impression of it.
Okay. What's up?
No.
Yeah, that first group there.
11.
Oh, these. I'm sorry. This is why I was thinking you guys just do the evens on that.
Oh my god.
So the evens on that one, then we'll have you do all the right in the functions on the bottom there. Okay?
Mr. Murphy,
What's up?
you come here. Okay.
All right. So then we'll make sure you guys go through all your stuff. And if there's leftover questions and junk about everything else, we're going to spend tomorrow going over a whole lot of review stuff. Okay?
I did not understand any of the stuff we did for homework now.
Right now it's zeros?
Like, I understood this. I understand what we did last night.